Hi, folks. Mike here from 3D Technologies, and I've been doing a lot of experimenting with different materials for to make functional parts. And functional parts need to be strong and they need to be resilient. Uh, you know, I like to make pretty things that are also functional, like, for example, the lamp back there, the mermaid lamp, which I'll be sharing with you in another video, later video. But functional parts, I make small tools and other things which serve a purpose. Like, for example, this little grip thing here. Uh, this is made from a PETG, Yoi PETG, and it works really well. It for sealing, a bag of chips or whatnot, or holding anything together. Uh, it works well. And Yoi Petchi is on Amazon. It's pretty cheap, and it works well. I've made a lot of different things from it. Um, but I've wanted to try out new materials and see if I could find anything better. So I went and I experimented with a bunch of different materials like ABS. And ABS, I've had poor layer adhesion issues with it, and it didn't really, I didn't like it at all. Uh, Somebody said try hips, so I did. Uh, Hips filament, and hips is like ABS, but they said that it's a little bit different. It dissolves in laminate, so you can use it for support material and stuff. But I just wanted to use it and see how it printed, and well, that didn't do so hot. I tried to. Had a couple of failures, and as you can see here, I had a warping issue, and that leg here came off the print bed, and I paused the print to uh, had to stop it. And I raised the temperature and to 110 on the bed from 100, and I got a complete print. But then when I tried to print it again at 110, I got another warp. This time the front end is warped. So you can see it's kind of bent, and it came off the bed. The front end did. So hips warps a lot. So and I've got an open printer. I've got a heated bed, but an open printer, and it's apparently not enough to prevent the warping. Uh, and on top of that, this is the print that came off of there, and it looked good. The problem is that when I flexed it, um, you can see there's this layer separation there. It's pretty bad. So it didn't take all that much force to cause that, and so the same issue that I've had with ABS before, where you have poor layer adhesion, and I had here, and I have warping, possibly worse than ABS with hips. Unfortunately, hips not for me. It's not going to work out. Like I said, people say that if you use ABS or hips for that matter in an enclosure, you get really good layer adhesion. Uh, you know, uh, I believe them, but it's never worked out for me, and I don't want to use an enclosure if I don't have to. There's other materials I can use. PETG works fine uh, without an enclosure. Another material that I've used is CPE, and CPE is this is a filamentum, and filamentum makes some really good materials. This is CPE, and I've had good luck with this material. This material is also very strong and heat resistant, more heat resistant than most. And I made lamps out of these and never had an issue. Um, I was expecting this to do really well, uh, but to my surprise, it didn't do that well. I don't know if you can see it on camera, but this thing is actually had the same issue. It had a layer separation issue, and you can see it from this angle maybe. when I flex it, you can see that, yeah, that part right there, you can see that there's a layer separation issue. It's not as bad a failure as the hips was, but it surprised me that it failed. And now, to be fair, this has been out in the open for quite a while, and I'm not sure how uh, that affects it. But but yeah, I was surprised. This filament CPE, like if you go into a vase mode and you make vases, um, you'll be able to make a watertight vase with this filament than you will with, let's say, regular PETG. Uh, you'll have to increase the flow less with this filament than you would with regular PETG. And because I've had so much success with the CPE before, I was expecting to have success this time as well, but it didn't work out that well. Surprised me. Um, so I again been trying different filaments. This one here is a fiberology PETG, and yeah, it works well. It's not bad at all. It feels a little bit stiffer than some of the other filaments that I've used, and works very well. Looks pretty good. So fiberology PET-G is not bad. Um, I haven't done a lot with it. I got a free sample to use, and this is what I use it for, and turned out well. Uh, some stringing, but you expect that with PET-G. Uh, and going along here, that was one of the PET-G filaments. I've been I've used something. I picked up a roll of something called PCTG, not PETG, but PCTG. And this here is also made by Fiberology, and this material has really impressed me. It has less. It still has some stringing, which kind of surprised me. They said it was supposed to print like PLA, which it kind of does, but only at a much higher temperature. That's another thing. This material prints at a much higher temperature. You need like 270 degrees on your hot end to get this to print right. And it's strong. It's stiffer than others. Um, like if I put my finger in there, it like pinches more than the others do. Uh, uh, it's really strong. I try to make vases out of these. And the what's unique about this material, other than it takes a much higher temperature to print with, it prints easy once you get it up to the temperature. It has a little bit less string than PETG, prints easier than CPE, uh, and it's got incredibly strong layer adhesion, inner layer adhesion. So unlike these other ones where you had the layer separation happening, no, you won't get that with this. I printed a vase and tested out some print and vase mode with this material, and it was very tough vases. Again, the CPE, you could get that watertight using less flow than you would with this for some reason. But this is really tough material for inner layer adhesion. It works really well. Um, Now, the strength and, the durability of it is very good. Um, I'm very impressed. Also, it looks pretty sharp. I don't know. That's a glassy end, and um, it's a pretty looking material. It's pretty red. Um, so I'm looking forward to using this a lot in my other projects. And I have a lot of other projects that I use. Um, like this here is a wallet that I've 3D printed out of that same Fiberology PCTG, and it is strong. It's very durable. Uh, and Another filament that I've found to be, I've tested. This is by 3D Fuel called Workaday PETG. And Workaday is their cheaper PETG. They have a pro version, uh, but Workaday is supposed to be their cheaper one. And this stuff is strong. It's yeah, it's really strong stuff. I love the way it works. I've printed a lot of things with it, and it's been easy to print with. It's been strong. It's been heat resistant. Really impressed. I'd like to try their Pro line as well if I ever get my hands on it. But all these filaments cost money, folks. It's not cheap to try different filaments. But so very impressed. I've been very impressed with the 3D Fuel Workaday filament and the PCTG. This one's by Fiberology. There aren't that many companies that make the PCTG, uh, but boy, this stuff is tough. It is really good inner layer adhesion on these. Um, and the thing that I found was kind of funny about these is that in order for this to work, it has a little surface here where your cards go in. Like I've got my wallet here, and this is made out of PET G, atomic PET G. Atomic makes really good filament. This is stuff sticks to the bed, doesn't warp, and it just prints beautiful. Uh, I don't think it's as strong as PCTG is, but I'm no complaints with this stuff. Uh, and the interesting thing is when I put these things in there, my cards, for example, go in there. You got to push down on it to get them to pop out. And even on this one, you got to kind of use a little bit of force to get them out, but you can't get them out. You can. I got three cards in there, and that's not an issue with this one. With this one, I can't. I can get three cards in there, but I can't get them out. And the reason I found out is, this one is kind of like the blue one where there's a little thing here that you push and it goes in a little bit. It got some give, so it allows for the card to slide in and out. This stuff is so strong that the only a part of it has give, and this part here has no give at all. So this material, you gotta kind of be careful about using it. It's not as slippery as PETG. I don't know if you call it lubricity or what it is, but uh, it, I can put three cards in here. I can't get them out. So if you want to use this, I'd have to only use two cards in there to get them regularly in and out. And so yeah, it's been really interesting to find out the different materials and how they work. And I'm really happy that I've done this experiment because I found PCTG and this stuff is really good. Um, for just for the hell of it, I decided to use my resin printer to uh, to print a wallet, and I used tenacious resin, which is clear, and it is strong, really strong stuff. But with resin, resin is tacky. Even if you wash it and cure it, it's still tacky. So when it comes to functionality for cars, you can't get anything out of this thing. The cars go in there and they stay in there, and you ain't gonna get them out. It's like glue in there. So it's. I just did it to see what it would be like, and it worked really well. It printed well, but it's not functionally. It's not working for the purpose that it was intended for. It's that tenacious resin is tough. I mean, they're not going to break this. Um, so other things that I've made is these go. Uh, these are clips that go in the visor and hold your sunglasses. Pop your sunglasses in there, and they hold it up. And I think PCTG will be a really good material for that application or for really any other application. I believe the glass transition temperature for PCTG is lower than it is for CPE or PETG, which is really weird because it prints at a higher temperature than they do. So I don't understand why that is, but I haven't had any issues with it. I haven't made any lamps out of this, and I would like to. I think they would look pretty cool, and I'd like to test that uh, one day. But yeah, PCTG is really cool. It's This one comes in a 750 gram spool, and it costs like $30 or $35. So it's a little bit more expensive than Pet G. Like the Yozi stuff, the Pet G, which is, I think I made this out of it, uh, is cheaper. So you get a whole kilogram for $20. Uh, and it works. It works fine. Uh, but this will be tougher. I can tell it will be tougher. And it has slightly different properties. Uh, and I'm looking forward to trying out a lot of other stuff. So um, that's about all I had for you today with functional pieces. I'll be making more videos about well, my new mermaid lamp back there. She turned out gorgeous with Pet G from Atomic Pet G, just Prince butter. It's no warping, no great layer adhesion, really good. Sticks to the bed and then comes off when you need it when it cools down. Uh, so, and I've been printing all of these on my CraftBot. The CraftBot printer, uh, well, I can do a review on that printer later, but it's a good printer that's been let down by some poor design and some bad electronic issues, but it's really should be a beast of a printer that prints really well. Um, but it does have some usability issues. I'll get into them later. Anyways, um, I hope you've enjoyed this video, and kind of wanted to, leave you guys with a Grateful Dead uh, 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 song. It's kind of Grateful Dead, one of the hardest working bands in the industry. They were, and they were never like flashy or anything. That they never hardly advertised either, and they had a great following. But anyways, people, all I gotta say is peace out, and hope you enjoyed the video. Thanks.